All right. So, logarithms. Let's define a logarithm. Okay. First of all, what we put inside a logarithm needs to be positive. The base needs to be positive, and the base can't be 1. 1 to any power is 1, so it does not make sense in a logarithm. Okay. So you tell me, if we have y equals log base a of x, that means the same as what? Our base is a. Our base is a. Okay. What represents the power in a logarithm?
X. P.
A is the base, raised to the y equals x. You must know how to rewrite logarithms. Your success on the Chapter 3 text will depend on you being able to rewrite logarithms. Okay? So, base A, the other side represents the power. Okay, the logarithm equals the power. The logarithm equals the exponent. And then x, what's inside the logarithm, that's what your a to the power equals. Okay, so let's practice. Okay, log base 2 of 16 equals 4. Because, how do we rewrite this? Base 2 raised to the 4th equals 16. 2 to the 4th equals 16. Log base 10 of 10 equals 1. Because, what's our base? What's our power? Equals 10. 10 to the first power equals 10. Log base 3 of 1 equals 0. How do we rewrite this? 3 to the 0 equals 1. Base 3, power 0 equals 1. Okay, now let's go the other way. What if I want to rewrite 2 to the... Oh, that was not a good example. That's not a good example. Because we already have that up here. I'm going to change it. That didn't work out so well. Okay, we'll just erase that example. 5 to the 0 equals 1. How do we rewrite that? Log base. What's the base?
1. Or, no, it's not.
5 is the base for the exponent. 5 is the base for the logarithm. Log base 5 of 1 equals our exponent of 0. The logarithm always equals the exponent. If you need a little pattern, base of 5, inside is 1, equals 0. Okay, it kind of has that same circular pattern. Okay. Okay, so let's talk about our properties of logarithms, okay? Some of you may have been reminded of some things that will happen as we've been rewriting these logarithms. Some of you might not remember logarithms at all, I don't know. Okay, but let's talk about the properties of logarithms, that way we can reduce logarithms, okay? So first one, log base A of 1 will be what? Zero. What's the reasoning there? Any base to the 0 power will always be 1. Okay? So rewriting this, a to the 0 power is 1. So if you have log of any base with a 1 inside, we know that's going to be 0. Because base to the 0 is 1. How about log base A of A? 1. Okay? Because a to the 1 is A. What about log base A of A to the x? Because if we rewrite this, base A raised to the x power equals a to the x. Okay, what does that look like? Okay, I'm going to go back a slide very quickly. This log base 2 of 16, okay, well, 16 is the same thing as 2 to the 4th, and so that logarithm is 4. Okay, that would be an example of that property. Okay. Okay, last one. If log base A of x equals log base A of y, then what must be true? X is equal to y. That's kind of like the exponent property we were talking about yesterday, right? I see. Those are the 4 properties. Okay, so let's go ahead and evaluate some logarithms. You can use those properties. You can rewrite to help you. I don't care. Okay. Log base 4 of 16. Okay. If you want to think about it, we know that this would be 4 to what power equals 16? 2. Log base 5 of 1. 0. Because 5 to the 0 is 1. Okay. Anytime there's that 1 inside your logarithm, it's going to be 0. Log base 4 of 2. 1/2. Because 4, this is how I like to think about it. 4 to what power is 2? 4 to the 1/2 power is 2. Log base 3 of -1. You see some puzzled looks. Why? Let's think this through. Can we take 3 to the power and get a negative value? No, that is not possible. Okay, that's why we have that horizontal asymptote on our exponential graphs, right? We can't get negative values when we're talking about powers. So if we rewrite this, 3 to what power is -1? Okay, that can't happen. This is undefined. We cannot put negative numbers inside of our logarithm. It does not make sense. Okay, let's talk about that base E. Base E is special, isn't it? When we have a logarithm with base E, what do we call it? The natural logarithm. Okay, so the natural logarithm is log base E, which we write as the natural log of x. Okay, now since E is an irrational number, okay, a lot of times we're going to get some irrational values out of the natural logarithm. Okay, so get your calculators out and make sure you just know where the natural log button is. Okay, it should be the same button as your e to the x, but I just want to make sure you know where it is. And to find it, punch in natural log of 10. Just make sure you get that 2.3. What? You want natural log, ln. So instead of saying second for your e to x, it's just the ln button. Oh, okay, you put log 10, natural log. Oh. All right, so let's rewrite this as in exponential form. What's our base for our logarithm? E. So e to the 2.302, since it had to be approximated, is approximately 10. Right, log base e to the power equals 10. What about e squared equals approximately 7.3890? How do we rewrite that in logarithmic form? So log base e of equals 2. Okay, don't write log base e, write the ln, the natural log. The natural log has the same properties as the rest of the logarithms. Okay, so you still have, you know, you still have natural log of 1 is going to be what? Anything with 1 inside the logarithm is going to be 0. Okay? Natural log of e would be 1. natural log of e to the x would be x, okay? And then natural log of x equals natural log of y would mean that x and y would be equal. Okay, so we still have the same properties there. Now, what I want to focus on right now are graphs of logarithms. Okay, I have confidence that you guys can rewrite logarithms and evaluate them. So I want to take a little time and focus on the graphs of logarithms. Okay. First of all, I want to know what the relationship is between y equals 2 to the x and y equals log base 2 of x. What's the relationship? Yes.
Log 2x is rewrite it as 0.
Well, if we rewrite this, how would we rewrite it? 2 to the y equals x, right? Ah. Okay, look at how we rewrote this compared to this right here. What's different between these two? X and y switched places, which means, like Nate said, we have inverse functions. Okay, so 2 to the x and log base 2 of x, these two are inverse functions. Okay, so up here I have graph 2 to the x. If I ask you to graph 2 to the x, what points do I make you pick? -1, 0, 1, right? So we have -1, 1/2, 0, 1, and 1, 2. Okay? So if I want to graph the logarithm, what do we do with those points if we have inverses? We switch x and y, right? So 1/2 the point -1, 1/2 becomes what? 1/2 -1. The coordinate 0, 1 becomes 1, 0. And the coordinates 1, 2 becomes 2, 1. Okay. There is our logarithm. Now, our exponential graph has a horizontal asymptote. What's going to be true about our logarithmic graph? It has a vertical asymptote at x equals 0. So this is what I want you to notice about the logarithmic graph here. Okay. Well, first of all, these coordinates switch places. So now, where is our -1, 0, 1? In the y column, right? So when we talk about graphing logarithms, I still want you to think about that -1, 0, 1, those points. But when we're talking about logarithms, since they're inverses, it's going to be in the y column. All right? So let's talk about graphing this. Log base 3 of x. Okay? This is a parent function. We have no shifts. Do you agree? Okay. So this is what I would expect to see for a graph. Here is our parent function. What? We talked about there's an asymptote. Where is it? X equals 0. Okay. we cannot have negative numbers in our logarithm, and so that asymptote is bounding us from ever doing that. Okay, don't put any zero or negative numbers in your logarithm, it will not work. Okay, so that's why that vertical asymptote is there. Now let's pick our coordinates. Since logarithms are inverses of exponentials, our x and y switch. So negative 1, 0, 1 is going to go in the y column. Okay. What number will we need to put inside the logarithm if I want my y value to be negative 1? A third. Notice how these points are familiar. Okay. If I want my y value to be 0, what do we put inside of our logarithm? 1. Okay. And if I want my y value to be 1, what do we put inside of our logarithm? 3. Okay. These points are just flipped from 3 to the x. Okay. So 1/3 negative 1, 1, 0, and 3, 1. Okay. Let's talk about our domain. What is the domain of this function? Very good, 0 to infinity. What about the range? What's going to be true about the range for every single logarithm that you graph? Always going to be all real numbers. Okay, no matter how we shift that graph around, our range is always going to be all real numbers. Crazy, because the domain of the exponential graphs are always all real numbers. Okay, see how they're related, right? Switch x, y. Okay, now let's talk about if we have some shifts. Okay, here again, I want you to think about the parent function and then make your shifts. Okay. So our parent function is log base 3 of x. Okay. And we just talked about that parent function. We put negative 1, 0, 1 in the y column and figured out what x's made that true. Okay. Now, what are we going to do with those points to get log base 3 of x plus 1 plus 2? That x plus 1 is telling us to do what?
The left one.
Left 1. And then that plus 2 is telling us to go up 2. So let's start at the bottom. 3, 1. If we move left 1 and up 2, we're at the coordinate 2, 3. If we take our coordinate 1, 0 and we move left 1 and up 2, we're at the coordinate. And if we take 1/3 negative 1 and we move left 1 and up 2, we're at the coordinate negative 2/3 positive 1. I want you to think carefully here before we draw on our curve. Is our asymptote still at x equals 0? No, where has it moved?
Negative 1.
X equals negative 1. Okay, now since we have a vertical asymptote, horizontal shifts are going to move that around. So since we had a shift to the left 1, our asymptote will be shifted to the left 1. for this graph, what's our domain? Great. -1 to infinity. And always for a logarithm graph, what's our range? All real. Okay. Something that will be a part of your homework when you graph, they're going to ask you to find the x-intercept. Okay. So let's practice finding the x-intercept. X-intercept means what? What does the x-intercept mean? Where the y value is 0. How do I figure out where the y value is 0? Okay, so I put 0 in for y. How are we going to figure this out? Okay, we're going to have to change it into exponential, but not yet because of that plus 2. So we're going to subtract the 2 first. Then we can rewrite it as so 1/9 is x plus 1, which means our x-intercept is at -8/9. Now, I'll come back. Does that look about right on our graph? It's getting pretty close to that -1 asymptote. So our x-intercept is at -8/9, 0. Okay. So you will have to find those x-intercepts when you graph in your homework tonight. Very quickly, let's talk about the graph of our natural logarithm. Okay. So this is just log base e, remember. We're still going to have an asymptote at x equals 0. Okay. And then when we think about the coordinates of this graph, since it's a logarithm, we want -1, 0, 1 in the y column. Okay. Let's think of this in terms of e. What number would we put into the logarithm to get out -1? What number did we put into this logarithm to get -1? 1/3. So what about here? 1 over e. What do I plug in to get 0? And what will we plug in to get 1? Okay. Obviously, we'll have to approximate those to put them on our graph, but there's our natural logarithm. Yes. When we're talking about logarithms, that's where we're going to put them because they are inverses of exponentials, and so the x's and y's switch places. So we'll do that with our logarithm graphs. Okay. One more thing, and then I'll let you have time to work on homework. I don't know if I really need to do this example or not, but we'll talk about it just in case. If I asked you to solve this equation, look at it for 2 seconds, what would you do? set what equal?
So,
What is inside our logarithm? If I have two logarithms that are equal and they have the same bases, what is inside should be equal. So we get x equals -2. I didn't know if I would need to do one of those, but just in case, there you go. You have 10 minutes. I expect you to be working all 10 minutes. Okay? Remember, you have to graph the logarithms, okay? Logarithms without base e, you have to graph without a calculator this Friday and next Friday. So please practice them that way. Think about the parent function and then do your shifts or any transformations that you have.